Hi guys, my name is Vinay Jain and today we're going to be discussing Leetcode question 543, diameter of binary tree. So the question is, given the root of binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in the tree. This path may or may not pass through the root. The length of the path between two nodes is represented by the number of edges between them. So let's understand this question. So let us assume this is the tree that we have, with root node being the node 1 on the top. So what exactly is the length of the tree? First let's discuss length. So let's say if this is the tree that we have, the length between, let's say, node 1 and node 2 here is 1 because there's only one edge between them, right? So the length in this case is 1. Let's say if we're discussing for this path, for the length between node 2 and node 3, length between node 2 and 3, that is equal to, this is one edge and this is the other edge, so total 2. This is the length. So now we have understood the length. Let's understand what the diameter actually means. So diameter, as said, is the longest part between any two nodes in the tree. So in this scenario, in the given scenario, what is the longest path? As we can see, the longest path is this, starting from node 4. This is one edge, this is second edge, this is third edge, this is fourth edge. Do you really think it's the longest path? Let's check the other path possible. Let's say if we take this for example, this path is first length 1, this is length 2, this is length 3, this is length 4, and this is length 5. So therefore the diameter of binary tree is length 5, which comprises of nodes 3, 1, 2, 5, 6, 7. So this is what makes up the diameter of the binary tree. So now let's consider another example to exactly understand, will the diameter always pass through the root or not. So let's say this is the tree that we have. Sorry, my bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now in this, if we carefully analyze, the diameter of the tree with the longest path between any two nodes is actually this path. And this path does not pass through the root node. So the path that actually makes up the diameter of the tree is 10, 9, 8, 4, 3, 5, 6, 7. Note that this path does not include the root of the node. So the diameter is not necessarily something that passes through the root of the node. And what is the length here? In this scenario, length between 10 and 7 is, this is 1, 2, 3, 4, 5, 6, 7. So this is the diameter of the binary tree. So how can we programmatically compute this? So for that, let me clear this for a moment. On the right hand side, you can see some formulas and conventions that I've written. This is what we use to solve this problem. One thing that you need to note is, if the height of null tree, if it's a null tree, the height of that is considered to be -1, as here given here, and the convention 2 is height of a leaf node is 0. These are the conventions. Now based on these conventions, we will use these two formulas. Diameter of any tree or subtree or any node is calculated by 2 plus left height, whatever the height of the left subtree is, plus whatever the height of the right subtree is. Then max height is calculated by 1 plus, that is the current height, max of whatever it gets from the left side or from the right side. The maximum of that is added to 1. Now before we proceed, let's understand why height of a null tree is -1. So let's say if we're at a null tree, let's say max height, let's say of null tree is -1. So let's say this is a leaf node 6, it's some coming from some branches, right? So let's say this is where we are at this place in the program at node 6. What is the max height of this? Max height of this is 1 plus what is the left hand side height? It's -1, right? What is the right hand side height? -1. So the max height is calculated 1 plus max of -1, that gives us 0, right? So the max height is of a leaf node is 0. Now once we have calculated that, what would be the diameter for this? Diameter for a leaf node, diameter would be 2 plus left height. What is the left height? It's -1. What is the right height then? -1. What is this? 0. So diameter of a leaf node is always 0. So these two things we'll be using just to ease our computations. Now that I've shown you all the basics that we need, we'll proceed to how to solve this problem. We're going to be using a form of tuple DH. D stands for diameter, H stands for height of the tree for every node for easy representation. Now let's start from the root node. We're going to be using a modified form of depth first search to complete this algorithm. So we're going to start from the root node, proceed to the leaf node in a postfix manner, where we travel to the leftmost side first, then to the rightmost side, and then we evaluate. So this is what we're going to be following. We go to the leftmost side, and then here we check, we go to the leftmost side, right? So this is where we reach first, and this is a leaf node, right? So the leaf node diameter is 0, height is also 0. Notice I'm using the convention D and H. So this is diameter and this is H, 0. Both are 0 right now. So once this is computed, we return the height, whatever the height is 0. So we return height equals to 0. That means the height of the left subtree is 0 in this case. Then we have come back to this node. Now we proceed to the right hand side. We evaluate the right hand side. We go to the right hand side and then to the left hand side of that. Here again, this is a leaf node. All leaf nodes will have 0, 0, 0 diameter and 0 height. So this is how we're going to work. Before we proceed, I'm keeping a parameter max diameter to keep track of whatever is the maximum value of diameter we have encountered so far, because this is essentially what we need, right? So now we proceed ahead. As I said, the function will come here. Now this is a leaf node again, so it will return height 0. It will return height 0, and then the program will proceed from node 5 to node 6. Since it has evaluated the left hand side, now it will go evaluate the right hand side and then the left side of that. This will again, since it's a leaf node, it will return 0 height. It will return height 0, sorry, my bad. And at this point, node 6 will evaluate its right hand side. Its right hand side is null, so this will return -1. So now at this condition, node 6 evaluates what is the diameter of this node at node 6. First we calculate the height. Height is 1 plus max of, from left hand side we get 0 and from right hand side we get -1. These are the values. So what is the maximum of that? 0, right? So height is, for at node 6, the height is, maximum height is 0. Sorry, 1. 1 plus 0 is 1. And what is the diameter? The diameter is 2 plus whatever is left hand side height, which is 0, and whatever is right hand side height, which is -1. So this gives us 1. Again, just to see that, we can see the diameter is, we only have a single edge. Therefore, the diameter in this case is 1. So for node 6, I'll just clear this out. So for node 6, we have a tuple of 1, 1. Now the control goes back to node 5, and from node 6, we return the value of height, which is 1 in this case. So this is what we return. So now 1 is returned. At this scenario then, at this node 5, we then evaluate, since it has evaluated left and right both sides, so now we evaluate the diameter here. The diameter here is, first we evaluate the height, 1 plus whatever is maximum from left and right. Max of left is 0 and 1. What is the maximum of that? That is 1. So 1 plus 1, this gives us 2. So diameter is 2 plus whatever is getting from the left hand side and whatever we get from the right hand side. So diameter is 3. Notice if we want to check the diameter, how is it 3? Just a moment, I'll clear this up a bit for easy understanding. The diameter is 3 based on 1, 2 and 3. These are the 3 edges that it's talking about. Now once we have calculated the maximum diameter, my bad, I forgot to say one thing. When we have computed the diameter here, since our max diameter currently is 0 and that is less than the new diameter that we have found, so we update the diameter. Once the control goes to node 5, we have calculated diameter 3, that is again greater than what we have so far, so we again update the max diameter. And now we have done this, so here we create a tuple of 3, 2 and then we return 2 from here because that is the height, right? So that is what we return. And now we have 2 here, so we calculate D and H here. First we calculate height, 1 plus max of left and height. So left, from left we have 0 height and from right we have height 2. So what is the max of 0 into? That is 2. So this gives us 3. Height is 3 at this case. That you can also verify. This is height 1, this is height 2, this is height 3. So height is 3 and what is the diameter? 2 plus whatever we get from right hand side and whatever we get from left hand side. So from left hand side we get 2, so this is 4. So diameter is 4, so we get a tuple of 4 and 3. Notice that the current diameter is greater than the max diameter we have, so we update max diameter by the current diameter 4. Now that we have computed this, now the control goes back to node 1 where node 2 returns the height it has computed so far, which is 3. So this is the value that is returned. Now node 1 evaluates its right hand side because it is done evaluating the left hand side. So it comes to the right hand side, and so this is also a leaf node, so it will have diameter 0 and height 0. And this will then return 0 to its parent calling function because that is what is to be returned as height. And now node 1 evaluates its diameter and height. Height is 1 plus max of whatever you get from left. From left you get 3 and from right you get 0. Right height is 0, right? So 1 plus max of 3 is 0 is 3. So 1 plus 3 becomes 4. So height is 4. What is the diameter in this case? Diameter is, So diameter is 2 plus left height, which is 3, and right height, which is 0. So this is 5. So at root node we calculate the tuple is 5, 4. That is diameter is 5 and height is 4. At this point you can easily verify this, that this is the height 1, this is the height 1, this is the height 2, this is the height 3 and this is the height 4, which is exactly what we have here for node 1. And if you want to calculate the diameter can also be calculated like it's seeing node 5, it's seeing the value 5 here, right? So how can we verify that? See, as we had initially checked, this is one length 2, length 3 from node to 5, 5 to 6 is length 4 and 6 to 7 is length 5. So therefore our diameter comes out to be 5 and we return this value. We update the max diameter and we then return max diameter, which is 5 in this case. So what is the algorithm for this? So the algorithm is, if we have a null node, we return height which is equal to -1. If leaf node, we return 0, which is the current height for the leaf node. We then recursively check into the left height and then we recursively check for the right height into left and right childs. Once we have done that, we calculate the new diameter. Diameter is calculated by this formula, 2 plus whatever is left height and whatever is right height. So this is how we calculate the diameter. Then we calculate the new height, which is calculated using this formula, again as seen above in the dry run. And then in the end, we always make a check. This is very important. If the new diameter that we have calculated here at step 5 is greater than the max diameter we have encountered so far, then we update the max diameter. And in the end of the function, we return the new height. So this is the algorithm for this problem. What is the time complexity? So the time complexity of this algorithm is, again, we are using a modified version of depth first search, right? So it's O, V plus E, where V is the number of vertices and E is the number of edges. I hope this tutorial helped you understand this question and how to solve it via the dry run and algorithm. Thank you for watching this video, guys. I'll attach the necessary GitHub repository links in my description below. Thank you for watching this video. Have a nice day.